Hello everyone, hello Mohi, good vibes, hello, yes, I'm here. Thank you for waiting a little bit. Hello Amya, hello Hassan, hello Lucas, hello good vibes, hello Sanskriti, hello Kaushik, Komal Kaushik. So today what are we going to do? Obviously you know, today we are going to discuss the numericals and mostly NCERT numericals, because in the past we have seen that NCERT numericals with slight changes are coming in your paper. Okay, so I will discuss the numericals from NCERT. Also I will tell you that how they have changed the numericals in your board exam. So everything we will discuss, and I expect your help because I do not have any calculator. So whenever there is a calculation arrives, you are supposed to solve it using, you are not allowed scientific calculators, so you have to use simple calculators. Okay, and I had done a video where I have explained how to read a tangent table. Okay, if you want I can again explain it tonight 8 p.m. I have another live. Okay, so before I start that live I will explain how to read a tangent table. If you are interested, just mention, sir, I want to learn about how to use sine. Cos is not important, but same way if you know how to read tangent table, you can same way you can read sine table and cos table as well. Okay, you don't need to be super accurate, just basic understanding is sufficient. And sine table, cos table and tangent table will be provided to you during your exam in your exam center. Okay, you will not be allowed to carry one for yourself. It will be provided by you to by the teachers. Okay, now let's start. So as I always mention that electric charges and field, electrostatic potential and capacitance, and alternating current, if you solve numericals from these 3 chapters, it is sufficient for you to answer 2 numericals. But for safety, you should also practice some numericals from ray optics and current electricity. Okay, these 2B should be your backup. That should not be your main plan, because sometimes numericals from ray optics and current electricity can be tricky. So always rely on these 2 chapters. From these 2 chapters, how many numericals we are going to get? We are going to get 1 numerical from these 2 chapters, and alternating current also we are going to get 1 numerical. Okay, so 2 numerical you are supposed to, you can answer easily if you practice some of the numericals that we are going to do today. Also I have done one more live in the past. If you can get time, you can check that out as well. Now let's start with the first question. 2 large thin metal plates are parallel and close to each other. On their inner faces, the plates have surface charge densities of opposite signs and magnitude 17.0 into 10 to the power of -2 coulomb per meter square. What is electric field in the outer region of the first plate, in the outer region of the second plate, and between the plates? It's basically a capacitor problem, but this question is from your electric charges and fields chapter in your NCERT textbook. If you open your NCERT textbook, you will see that last question of the chapter is this. Okay, in the latest print. Now here we have 2 charge plates. One is positively charged, one is negatively charged. Each of them have charge densities sigma. Okay, so what is the so this is region number 1, this is region number 2, okay, and this is region number 3. Now what is the electric field at 1 and 2? Electric field at 1 and 2, king of pirates, C equals to NEA VD, NEA by D. No, not that formula, Hassan. So solve the numericals of model question paper, please. Rakib, we have solved all the numericals of your model paper. Please have a look in 3-in-1 model paper. All the numericals of model papers are solved. But remember that in the past, in the history of board exam, no numerical came from model paper in the past. Okay, but numericals did came from your NCERT textbook. Many students ignore NCERT textbook altogether, but in the exam we have seen questions coming directly from NCERT, lifting the same question, changing it a little bit, and questions did came from NCERT textbook rather than your model paper. Model question bank, maybe, yes, question bank we did solve 2 sessions. Okay, 1 session recorded, 1 session live. You can check that out. Otherwise, model question paper even if you solve model question paper, you may not be able to answer the 2 required questions. Okay, be careful about it. Yes, pattern question might come, but exact question will not come, that is a guarantee, right? Okay. 17 into 10 to the power of minus 22, no. Yes, Jia, welcome. Just now we have started our first problem only. You have not missed out anything. So first of all, so this is specifically more focused on NCERT and some other problem as well. For example, alternating current, there are not too many problems in NCERTs. So we have to improvise on that. But first 2 chapters we have sufficient problems. Let's solve them. And as I mentioned that model question paper problems might come, but in the past, according to the history of the board exam, there never a question came directly from model paper, but there are instances where questions came from your NCERT textbook, so do not ignore that. Okay, this is a so this is a precaution to all of you. Now let us understand this question. So we know that this is a large, first of all, this is a large thin metal plates. So large thin metal plates, near a large thin metal plates, the electric field is given by sigma by 2 epsilon naught. Okay, this is the formula. This formula derivation, obviously the derivation is not there, is there in your textbook, but derivation is not important, but you have to remember the formula. Okay, electric field, I have shared one video of formula sheet, you can check that out, download the formula sheet, keep it with you just in case. Okay, so electric field near a charged metallic plate is sigma by 2 epsilon naught, and one is positive, another one is negative. So this is say positive, then electric field due to negative will be minus sigma by 2 epsilon naught. So electric field in the region 1, that is part A in the question. Part A in the question, electric field in the region 1 is given by EA, say, is equals to, so due to this plate, positive plate, it will be plus sigma by 2 epsilon naught, and due to negative plate, it will be minus sigma by 2 epsilon naught, so it will be 0. Okay, so net electric field at region 1 will be 0. Net electric field, if you remember how we derived the equation for capacitance, okay, capacitance, parallel plate capacitor. Maybe you have not done it because that is not an important question, but this is how we have done, we have derived the capacitance of a parallel plate capacitor. Okay, now electric field in the region 2, okay, region 2, it will be again the same value, minus sigma by 2 epsilon naught plus sigma by 2 epsilon naught. So again it will be 0. Now last is between the plates. Between the plates something happens, is because it is not super common, because what happens is that when you are considering this point, okay, electric field is outward this direction, due to this it will be inward. In this case it will be inward and this will be outward. Now what happens in between the plates, electric field due to positive is outward, electric field due to negative is inward. So in between the plates the electric field added up in the same direction, because both the electric field due to positive plate and negative plate, they are in the same direction, whereas outside the plate E plus and E minus, they are in the opposite direction. That's why they cancel each other. In between the plate electric fields added up. Okay, so in between the plate electric field will be, the net electric field will be E plus plus not plus actually, so it will be, let me write the electric fields, sigma by 2 epsilon naught plus sigma by 2 epsilon naught. Why? Because both fields are in same direction. So this is basic logic of field, okay, field related problem. So if this is positive, positive will be away, here negative, negative will be towards, and outside the plates they are actually opposite to each other and they cancel. Electric field near a large charged plate is constant. Electric field near a charged plate, which is a single plate, it will be constant, sigma by 2 epsilon naught. Now due to positive it will be outward, due to negative it will be inward. So if you consider only this plate, okay, electric field positive is outward, electric field due to negative is inward, so they cancel. Similarly, if you consider this plate only, electric field due to negative will be inward, electric field due to positive will be outward, they cancel. In between the plates, electric field due to positive is outward, electric field due to negative is inward, so they are in the same direction, so that's why they add up. Okay, understand this. So it will be sigma 2 sigma by epsilon naught or sigma upon epsilon naught. Now in this question, sigma is given by this value 17.0 into 10 to the power of minus 22, and epsilon naught we know 8.54 into 10 to the power of minus 12. So if you solve, what will be the value? 2 into 10, approximately 2 into 10 to the power of minus 10 and electric field, so Newton per coulomb. Okay. Yes, Bunny, 8 p.m. MCQ session will start. Most of the questions are from your question bank, and we will be solving them in detail. Okay, don't worry. Okay, so correct answer is, okay, if you solve it exactly, it will be 1.92 into 10 to the power of minus 10. I did an approximation because I think it is almost double. So it will be 1.92. 00 1.92 into 10 to the power of minus 10. Yes. Distortion check, it will be 10 to the power of minus 10, not minus 9. Okay, it will be 10 to the power of, because it is 17, not 1.7. Okay, it would be 10 to the power of minus 10. Yes. Yes, Hassan, correct. Approximately 2 into 10 to the power of minus 10 is correct answer. Okay, so be careful, easy question, but if you don't know the concept, you will not be able to answer this question. Okay, so make sure that you understand the concept before attempting any question. Okay, wait for some time, think in your head, try to understand the problem, then only attempt it. It is easy question, mathematically easy question, but conceptually it is a difficult question. Okay, now another question. Uniformly charged conducting sphere of 2.4 meter diameter has a surface charge density of 80 microcoulomb per meter square. Find the charge on the sphere. What is the total electric flux leaving the surface of the sphere? So similar question came last year, similar question. They did a printing mistake. Microcoulomb per meter square, they write it like micro, then small cm square. Okay, so they have done it like this, small cm to the power of minus 2. So people thought, what is this micro, what is this centimeter to the power of minus 2? So many students just wrote the question number and thought they will get full marks, but board says, okay, no, you will not get full marks. Either you consider it as microcoulomb per centimeter square, or you consider it as microcoulomb per meter square. Whatever way you solve it, that will be correct. You will not get any marks if you just write the question mark. Okay, so unless and until it's a very, very hugely wrong question, you will not get any marks if you just write the question mark. So you have to write the answer. The solution of the question was different. They asked what is the electric field inside and outside, but almost similar question. Okay, so this first part anyway you have to calculate. So uniformly charged conducting sphere of 2.4 meter diameter means diameter is given 2.4 meter. That means radius is half of the diameter. Don't make mistake. So you have to convert radius diameter to radius always. Okay, sometimes students forget to convert this small conversion and entire answer becomes wrong. Okay, so make sure you convert. If it is diameter or radius, read carefully and convert them properly. So radius is 1.2 meter. Charge density is given, so charge density sigma is given 80 microcoulomb per meter square. Okay, 80 microcoulomb per meter square. Don't get confused. If you see any micro centimeter square in this here, you have to understand this is microcoulomb per meter square. Okay, now what is the total charge? How to calculate the total charge? Total charge is very simple, 4 pi r square. Okay, let me do one thing. Let me write this as capital R. Radius generally represented by capital R. Okay, so capital R square. This is the surface area of a sphere because it is a spherical surface. Okay, it's a spherical surface. Surface charge density is given. So surface area times the surface charge density. This is the total charge. Now if you calculate total charge, 4 into 3.14 into 1.2, no conversion is required, it is given already in meter, okay, into sigma, which is 80 microcoulomb, means 10 to the power of minus 6, and the entire charge will be in coulomb. So this is the total charge on the surface of the sphere. Calculate and tell me the value. Who is doing it? Sir, these are enough to score full marks. Iconic. Yes, I believe that your numerical questions in the historical trend, you are going to get questions from your NCERT, maybe not exactly directly. For example, this question was asked last year and they changed the values, and they asked what is the electric field outside the sphere at a point. So electric field outside the sphere is given by obviously K, the charge that you have calculated, divided by r square, where r is the distance. Inside the sphere was also asked. This is the for point r greater than capital R, and electric field inside the sphere is 0 for distances less than r. Okay, so remember this. So if the similar question being asked this year as well, you just need to remember that kq by r square, electric field outside the sphere, and 0 for point inside the sphere. Okay, so just change this question, and it was asked in your board exam. So it will be 1446.9, okay, into 10 to the power of 6. So let me change it to 1.5. I will approximate it to 1.5 into 10 to the power of minus 3 coulomb. Okay, approximately. You can leave the answer that you got, but let me approximate this to this answer. Okay, 1.44 or 1.45 into 10 to the power of minus 3 is also quite acceptable. So this is the total charge. Now they are asking you what is the total electric flux leaving the surface of the sphere. Total electric flux leaving the surface. So electric flux from Gauss's law, we know that electric flux is charge enclosed divided by the epsilon naught, right? This is the charge, this is the electric flux. So electric flux is charge enclosed is 10 to the power of minus 3, and divided by epsilon naught is 8.54 into 10 to the power of minus 12. Okay, calculate this, and unit of this will be Newton meter square per coulomb. Remember, the unit of electric flux is Newton meter square per coulomb. Okay, because epsilon naught unit is little longer, so you will get Newton meter square per coulomb. If you forget, remember flux is nothing but electric field into area. Electric field is Newton per coulomb, and area is meter square. So if you multiply them, you get Newton meter square per coulomb. Unit is very, very important. If you do not write proper unit, 1 mark will be deducted. For both answers, suppose you make mistake in 2 units, 2 mark will be deducted without proper units. Okay, hello flute soul, welcome. So it will be 8.854. Okay, my mistake. Okay, calculate this. It will be 0.175, but there will be 10 to the power value, no? It will be 10 to the power of plus 9. 10 to the power of plus 9, because it is minus 3 minus 12, so it will go up and become plus. So if you are writing 0.16, if you are writing this as 0.16, it will be 10 to the power of plus 9. Okay, Newton meter square per coulomb. Okay, 0.16 into 10 to the power of 9 Newton meter square per coulomb. Okay, so answer is 1.6 into 10 to the power 8 Newton meter square per coulomb. And I think the NCERT solutions, if you have NCERT book, the answers are given at the end of the book. So from there also someone can be copying the answer, but don't worry, if you have understood, as long as you have understood, that is fine. Sir, can we take K value 9 into 10 to the power of 9? Yes, K value 9 into 10 to the power of 9 you can take, of course. Okay, if you are solving this question, just remember that if you are solving the question like this, you mention K equals to coulomb constant equals to 9 into 10 to the power of 9 SI unit. Okay, if you do that, you will get full marks. Otherwise, what you can do, you can write 1 by 4 pi epsilon naught, and then you can put 1 by 4 pi epsilon naught is equal to 9 into 10 to the power of 9. That is also okay. Whatever method, if you are writing using K value, K method, then you have to mention this is Coulomb's constant. Okay, or you can mention K equals to 1 by 4 pi epsilon naught. That is also fine. Okay, but 9 into 10 to the power of 9, yes, you can take. Okay, generally they provide it in the question. If it is not provided, you can take it closing your eye, no problem. Careful measurement of the electric field at the surface of a black box indicates that the net outward flux through a surface of the box is 8.0 into 10 to the power of 3 Newton meter square per coulomb. What is the net charge inside the blocks? If the net outward flux through the surface of the box were 0, could you conclude that there were no charges inside the box? Why or why not? So black box, the flux is given this. Flux is given. So flux is given, that is Q enclosed by epsilon naught is given. Okay, Q enclosed by epsilon naught is given, and they are asking you what is the net charge inside. Net charge inside, that is Q enclosed equals to phi into epsilon naught. Phi is given here 8 into 10 to the power of 3. Epsilon naught is 8.854 into 10 to the power of minus 12. So it will be 70 point something, okay, into 10 to the power of minus 9. Calculate it. Second part answer I want to ask you. 70.8 into 10 to the power of minus 9. Okay. Okay, 70.8 into 10 to the power of minus 9. This is the charge enclosed. Second answer, if net outward flux through the surface of the box were 0, could you conclude that there were no net charges inside the box? No charges inside the box. Okay, what is the meaning of that? So it means that the net charge is 0. So total charge enclosed is 0, but that does not mean that all charges are 0. There are no charges, because it can mean that we can have a plus charge, we can have a negative charge. Okay, so that means even if there are charges, if the charges are equal and opposite, the net charge would still be 0. Okay, but the flux will be 0, but we cannot conclude that the total charge is 0. No charge inside the box. Total charge is 0, we can conclude. Net charge is 0, we can conclude, but we cannot conclude that no charges are there inside the box. For example, even if you consider an atom, okay, atom has a positive and negative electrons orbiting around it. Total charge is 0, but total flux will also be 0. If you consider a Gaussian surface, net flux will also be 0, but still net flux is 0, net charge is 0, but no charge present inside the box, you cannot conclude that. So that means you cannot conclude no charges are present. It can have equal amount of positive and negative charge, but that does not mean that net charge no charge is present. Okay, so 7 into 10 to the power of minus 8 coulomb and no charge. No. Yes, exactly, Salma. Sir, how much I can score if I do all these numericals? I am expecting you should be able to answer all the both the numericals, and you should be able to score 10 marks. Okay. Now next question. 2-point charges QA equals to 3 microcoulomb and QB equals to minus 3 microcoulomb are located 20 centimeter apart in vacuum. What is the electric field at the midpoint O of the line joining the charges? If the negative test charge of magnitude 1.5 into 10 to the power of minus 9 coulomb is placed at that point, what is the force experienced by the test charge? This question came in 2024, I think. I'm not sure first paper or second paper, but this question came in 2024 paper. Okay, now how to answer this? Obviously try to if required to explain the answer, draw the diagram. Diagram is not compulsory, but if for your own understanding, if you are drawing the diagram, draw it in the answer sheet as well. Okay, because that gives an impression to the teacher that you have solved this question on your own, you have not copied from your next neighbor. Okay, so that is very, very important. Sometimes impression is important. So QA is 3 microcoulomb, QB minus 3 microcoulomb. So this is point A, this is point B. Midpoint O, midpoint O joining the charges. So 20 centimeter apart, the total distance is 20 centimeter. That means from the midpoint, this is at 10 centimeter, this is also 10 centimeter. Okay, now what? Now you have to calculate the net electric field. How to calculate net electric field? Due to positive charge, electric field will be away. Due to positive charge, electric field will be away. So this is our electric field A. And due to negative charge, the electric field will be towards. So this will be also in the same direction, and both charges are in equal magnitude. Now in the exam paper, you might get a question where charges have different values. So then you cannot use the shortcut that I am using, but otherwise the method is same. Okay, so suppose both of them are positive. Suppose one is 2 microcoulomb, one is 6 microcoulomb. Then both will be in the opposite direction, but it will be, the net electric field will be in the larger charge, towards the larger charge, okay, or away from the larger charge based on the sign. Okay, so make sure, understand this. For positive charge, electric field is always away. Due to negative charge, electric field is always towards the charge. Okay, based on these directions, either you have to add them or you have to subtract them based on the question. So this is a very typical question that might come in your exam day after tomorrow. Okay, so how to solve this question? Now because the charges are same, okay, value magnitude wise, and distances are also same, okay, I am using a shortcut that's saying that electric field due to A equals to electric field due to B, okay, magnitude wise, and that electric field say E. Okay, so the electric field, say that electric field is E. Now what is this value of E? E is K, any one of the charges, I am taking A, divided by the distance square. Okay, so lot of things to learn from this single problem. Obviously K is Coulomb constant, so 9 into 10 to the power of 9. QA is 3 microcoulomb, that means 3 into 10 to the power of minus 6. Do not miss out on this micro or nano. Okay, micro, nano in case of capacitor, pico, so everything is important. Divided by R square, because electric field is R square. Now here the distances are in 10 centimeter. Now many students tend to convert 10 centimeter into meter by decimal, and they confuse and they lost their way. I always recommend, do not use decimal, instead use 10 to the power of minus 2. So 1 centimeter is equals to 10 to the power of minus 2 meters. Okay, always remember this. If you remember this, you will be able to avoid some of the mistakes. Okay, this is very important to understand. All the toppers actually use this method. Okay, this avoids unnecessary decimal complexities. even though you are allowed to use calculators, many students make mistakes while calculating, even though. Now it is 10 into 10 to the power of minus 2 whole square, you will get 100 into 10 to the power of minus 4, that is 10 to the power of minus 2. Okay, so if you simplify this one, you will get 10 to the power of minus 2. Now why this is advantageous? Because it just goes up and becomes plus. So 10 to the power values you can simply add. So you will get 27 into 10 to the power of 5. 3 plus 2, 5 Newton per Coulomb. So this is the net, this is electric field due to one of the charges. So what is the net electric field? Net electric field is basically addition of EA plus EB, that is 2 into E. Okay, so net electric field is twice of this value, which is 2 into 27 into 10 to the power of 5 Newton per Coulomb, or 54 into 10 to the power of 5 Newton per Coulomb, or you can write 5.4 into 10 to the power of 6 Newton per Coulomb. Not required, but anyway. Now next part, so this is the part A, this is the answer for part A. Now we have to find the answer for part B. Clear? Understood? Any doubt? Yes, F equals to, okay, F is equal to 8.1. Let me see. I'll see your answer. Let me calculate that. Yes, Amaya is correct about the electric field. Salma, what is your, what are you saying? Yes, Moi, I'll check. Okay, now if you avoid, now in this class you have understood, but make sure you do the same process in the exam hall as well. Okay, don't deviate from this. So force is obviously charge into net electric field. Okay, so charge is given 1.5 into 10 to the power of minus 9 into 5.4 into 10 to the power of 5. So it will be 5, 2.5, 7.5, 7.9, approximately 8 into 10 to the power of minus 4 Newton. 8 into 10 to the power of, it should be 10 to the power of minus 4. Okay, 10 to the power of minus 9, 10 to, okay, sorry, yes, correct. I am wrong. You are correct. Yes. 10 to the power of 6 was there, no? So 10 to the power of 6 means 10 to the power of minus 3. Yes, 8 into 10 to the power of minus 3. Yes. Previous question, Komal, which question? Last one, this one. This one you want me to repeat? This one is easy question, no? Second answer, second option. Part B, okay. So, part B is very simple. Just understand that net charge or total charge is 0. If electric flux is 0, that means total charge enclosed is 0. Total charge enclosed is 0, but total charge enclosed 0 does not guarantee that it does not have any charges. It can have equal amount of positive and negative charges. Okay, it can have equal amount of positive and negative charges such a way that the sum of these two charges is equals to 0. Okay, sum of these charges equals to 0, but no charges inside the box we cannot say for sure. We can say that net charge is 0, we can say that total charge is 0, but no charge objects are present, that we cannot say. I gave you one example of an atom. Atom is by default is electrically neutral. It will have equal amount of positive and negative. So if you construct a Gaussian surface just around a single atom, you don't need to consider a box. Okay, if you construct a Gaussian surface inside around an atom, the net flux will be 0 from this atom. Okay, because total charge is still 0, but it still have a positive charge, it still has a multiple of negative charges. But that does not mean that electric flux is there, because net charge is 0. Net charge can be 0. Net charge is 0, obviously we can say. But here it is mentioned no charges. No charges means devoid of all the charges, or no at all, no charge particle is present, no electron, no proton is present. That we cannot say for sure. Equal amount of proton and electron can be present inside the box, okay, but no charge present, we cannot say that. So that is not, so we cannot conclude that there are no charges present. We can conclude net charge is 0. Remember, you have to write, we can conclude net charge is 0, but net charge 0 can be explained by having same amount of positive and negative charges. Okay, so that is why net no charges 0, we cannot say that. Okay, clear? Now next, okay, correct. Let's move on to the next question. A conducting sphere of radius 10 centimeter has an unknown charge if the electric field 20 centimeter from the center of the sphere is 1.5 into 10 to the power of 3 Newton per Coulomb and points radially inward. What is the net charge on the sphere? So here we have a sphere, okay, and it mentions that from the center of the sphere at a distance 20 centimeter, the radius of the sphere is 10 centimeter, okay, at a distance of 20 centimeter the electric field is given and it is radially inward, so this also has a meaning of it. So what is the net charge on the sphere? So if net charge on the sphere, say Q, if net charge on the sphere is Q, then we can say that the electric field at a distance of 20 centimeter outside the sphere. So first of all you have to check that whether the distance and radius are greater or smaller. So here obviously distance is greater than radius. So for this we can say that electric field outside the sphere is given by KQ upon R square, and it is radially inward. So inward means it will be a negative electric field. Inward electric fields are negative, outward electric fields are positive because the charge will be negative. We will see that. So what is the net charge? Net charge will be E minus E R square divided by K. Okay, so the net charge will be E R square divided by K, that is equals to 1.5 into 10 to the power of 3 into 20 centimeter. 20 centimeter means 20 into 10 to the power of minus 2 whole square divided by 9 into 10 to the power of 9. Now simplify this and tell me the answer. Okay, Mohi answered quickly, Gia also answered, Distortion also answered, Shibash, don't be scared. Shibash, this is not sure question, but based on these questions you will get questions, okay, that is for sure. But exact this question will come, you will memorize in your head and write, that is not going to happen. But based on this question, if you are able to understand these questions, how it is being solved, what is the answer, why this answer is like this, then you will be able to answer the question that is coming in the exam. That is for sure, okay. All the essential ingredients are here. Now in the exam what teachers will do, they will take some question from, some idea from there, some idea from here, and they will mix up and give you a question. You think, oh, this is a complete new question. Actually, if you break it down, all the concepts are here. This is basically, now if I give you one more question, what is the electric field at a distance of 5 centimeter? What is an electric field at a distance 5 centimeter? Now the distance is less than radius, so electric field will be 0. Generally, if this question is coming, they will add one more part to this question, that they will say, now calculate the electric field at a distance 5 centimeter. Okay, that will be 0. Okay. Clear? It will be minus 6.67 into 10 to the power of minus 9. That's what you got, most of you, and I guess that is correct. Okay. What is Nagaraj? What is your question, query? Yes. So minus 6.6, this is Coulomb, or minus 6.67 nano Coulomb. You can answer it like this as well, but not necessary. If you write it as Coulomb, that is also acceptable. Okay. Easy question. Now electric field, at a distance 5 centimeter from the center. They will not say inside or outside. They will just mention electric field at a distance 5 centimeter from the center. Electric field at a distance 5 centimeter from the center will be 0 because the point lies inside the sphere. Okay. So you have to mention that R is less than equals to capital R. So electric field will be 0. Okay. Yes, Salma, correct. Now, next, before continue, those you know that we have already launched KC30, and we have also launched our offline crash course, Lakshya KCET offline crash course. And if you register yourself today, you will get 3,000 rupees of welcome bonus. And the link of all these courses are given in the description section of this video. You can click there and register yourself. One very important announcement: ABHYAS KCET test series is now available for only 999, which was launched at 1499, and KC30 crash course, where we will be teaching, initially launched at 2499. It increased and then again it came back to 2499 again because of Holi. So obviously today many of you are celebrating Holi, even though Holi was yesterday, but many of you have not celebrated because of many things. So I have seen what in my neighborhood many people are celebrating Holi today. So this is the limited time offer. If you are interested after your exams are over, if you are really interested in ABHYAS KCET test series or KC30 crash course, do register yourself today. Okay, till the offer is there. Now let us move on to the next chapter. Electric potential and capacitance. In a parallel plate capacitor with air between the plates, each plate, now this chapter in my opinion is important this year. Okay, this chapter is important this year for numerical. My opinion, I can be wrong. In the past the pattern has changed, but what I am expecting, because last year the numerical question was from electric charges and field, and theory was from electrostatic potential chapter, maybe they will reverse the order this year, because this is always happens in the past as well. Okay, so one year they will ask a numerical question from the first chapter, the derivation from the second chapter, and next year they reverse the pattern. But it had happened in the past that repeated years had the same pattern, so you cannot trust that pattern, but there is a little higher chance in my opinion that numerical question will be from this chapter and theoretical question will be from the first chapter, but you cannot take that for granted. So that is very important. In a parallel plate capacitor with air between the plates, each plate has an area of 6 into 10 to the power of minus 3 meter square, and the distance between the plates is 3 millimeter, sorry. Calculate the capacitance of the capacitor. If this capacitor is connected to a 100 volt supply, what is the charge on the each plate of the capacitor? Easy question. So capacitance is given by, someone wrote the formula at the beginning, which is for air capacitor A epsilon naught by D, as simple as that. Only thing is you have to convert the units properly and write the value. So area of the plate is given here as already in meter square. It is given in meter square. In exam, remember, if the same question comes, they might give it in centimeter square, or they might say that it's a circular plate of certain diameter. So you have to calculate the area using pi r square formula, diameter to radius, and then calculate the area. So this is the formula. So similar concept based question might come, but they might change the language, saying that it's a spherical plates of a circular plates of a parallel plate capacitor of diameter, say 2 millimeter or 1 millimeter. So in that case you have to convert diameter into radius, then calculate the area, then you can use this formula. Okay, this may not be this direct as given in the NCERT book, but the concept might be repeated. Okay, so make sure I am telling you all the variations that is possible. And distance between the plates is 3 millimeter. Millimeter means 10 to the power of minus 3. Centimeter minus 2, millimeter minus 3. Okay, so 10 to the power of minus 3, 10 to the power of minus 3 cancels. 3 and 6 cancels. We get 17 point some value, 17.7 I think, into 10 to the power of minus 12 farad. Unit of capacitance is farad, or 17.7 picofarad. 17.7 picofarad. Yes, correct. Yes, yes. Now what next? The capacitor is connected to 100 volt supply. What is the charge on each plate? So Q equals to C into V. Q equals to C into V. They can ask energy stored. Energy stored is half CV square. So all variation is possible from here. So C is, we have calculated 17.7 into 10 to the power of minus 12. Voltage is 100 volt and charge will be in coulomb. So 17.7 into 10 to the power of minus 10 coulomb, or in shortcut you can write 17.77 into 10 to the power of minus 9 coulomb. This is optional. I am telling you, you don't need to do that, but you can do that. It is not forbidden, okay? So this, you can leave your answer here, you can leave your answer here as well, but make sure units are proper, okay? Answer is proper. So correct answer is 17.7 picofarad and 1.77 nano coulomb. Yes, correct. Amya, Mohi, all of you are correct. Okay. Mohi, if you are using 17.7, no, it will be 10 to the power of minus 10. It will not be 10 to the power of minus 9. 10 to the power of minus 9 means it will be 1.77. Okay. Make sure your 10 to the power calculations are proper. Okay. Check twice. Check twice. Two charges, 5 into 10 to the power of minus 8 coulomb and minus 3 into 10 to the power of minus 8 coulomb are located 16 centimeter apart. At what points on the line joining the two charges is the electric potential 0? Take the potential at infinity to be 0. Now this part is okay, just an information that potential at infinity is 0. Now here, when two opposite charges are there, 5 and minus 3, and you are finding electric potential can be 0 at 2 points. One point can be between the charges and one point can be outside the charges as well. Generally it is on the side of the negative charge, smaller charge, sorry, not negative charge, smaller charge. If the positive was smaller, it would be in this side. If it negative is smaller, in this case it will be on the negative charges side. Okay, so for this case, suppose this distance is x and electric potential 0 at some point here as well, that will be say y. Okay, so be careful. For two charges equal, for electric field it will be 0 outside because both are opposite charges, but for electric potential it will be 0 between the charges as well as near the smaller charge as well, because electric potential is a scalar quantity. Okay, so direction does not matter, only magnitude matters. So if this distance is x, this will be 16 minus x. Now if the question is asked such that at what point between the charges electric potential is 0, then you just need to find this point. If they said at what points, that means both point you have to calculate. Clear? Okay, so if it is points, mentioned points is plural. Okay, point bracket s means, point bracket s means it is a plural quantity. Okay, both charge positive means 0 potential not possible. Both opposite charges means potential will be 0 at somewhere between the charges and somewhere near the smaller charges, smaller charge. Okay, so this is x, this will be 16 minus x, this is y, and this will be 16 plus y. Okay, now let's start. First case, case number 1, first point, point 1. First point is where? Between the points, between the point charges. Okay, so electric field due to the positive charge, not electric field, sorry, electric potential due to the positive charge is K into 5 into 10 to the power of minus 8 divided by R. Okay, divided by R, here R is x. Remember, there is no square for potential. For potential it is only distance R, not R square. Okay, now let's put that value. Now let's say this is in centimeter, okay, this is in centimeter. So x centimeter means 10 to the power of minus 2 you have to add. Okay, so this is in centimeter because 16 is also in centimeter. So distance x has to be in centimeter. So you have to convert this as well. So this is a very tricky question. If you don't understand, please mention in the chat. I will explain twice if required. Okay, 9 into 10 to the power of 9, 5 into 10 to the power of minus 8 divided by x into 10 to the power of minus 2. So it will be 45 into 10 to the power of 3, that is 45,000 divided by x. Okay, 45,000 divided by x. 9 minus 8 is 1 and these two will go up, become plus 2. So 10 to the power of 3. 10 to the power of 3 means 3 zeros. So this is V plus. What about V minus? V minus will be again same thing, 9 into 10 to the power of 9 into 3 minus 3 into 10 to the power of 8 minus 8 sorry divided by 16 minus x into 10 to the power of minus 2. Again this is in centimeter, so this is in centimeter means 10 to the power of minus 2 will be common and you get minus 27,000 divided by 16 minus x, and net potential is 0. So net potential is 0, so it will be V plus plus V minus equals to 0. Net means what? Net means just addition. Okay, so net potential is 0. Now just add them. 45,000 by x minus 27,000 by 16 minus x equals to 0, or 45 by x equals to 27 by 16 minus x. Okay, 3 zeros will be common and cancelled. Okay, now let's simplify. 5 and it will be 3. Now cross multiply. 5 16s are 80. So 80 minus 5x equals to 3x. Okay, or 8x equals to 80, or x equals to 10 centimeter. So x equals to 10 centimeter is the answer. Now here x is from which point? From 5 into 10 to the power of minus 8 charge. You have to mention that. Okay, from 5 into 10 to the power of minus 8 coulomb charge. Okay, now what about the point y? Now let us calculate the point y. Similarly, we can now, I will write the equation at a one go. So V plus for point 2 near minus 3 into 10 to the power of minus 8 charge. Okay, V plus plus V minus equals to 0, or V plus is K K into 5 into 10 to the power of minus 8 divided by 16 plus y into 10 to the power of minus 2 equals to K into 3 into 10 to the power of minus 8. I am just doing one step jump. Okay, I am doing one step jump. So you have to write the negative sign, then you can take on the other side. Okay, but I am doing one step jump. K cancels, 10 to the power of minus 8 cancels, 10 to the power of minus 2, 10 to the power of minus 2 cancelled. So we get 5 by 16 plus y equals to 3 divided by y. Now cross multiply. 5y equals to 48 plus 3y, or twice of y equals to 48, or y equals to 24 centimeter from minus 3 into 10 to the power of minus 8 coulomb charge. Clear? Hello Pranav. No. Amya, check your answer. Salma, we are going to solve 20 questions and I hope that we will be closing 20 plus 1. I will be closing the session by 6. Okay, 6 to 6:30 I will be closing, because from 8 there will be one more session, that will be longer session. Okay, so have your dinner and get ready. Okay, that will be a longer session. So let's see the answer. 10 centimeter from 5 and 24 centimeter. It is not 40, it will be 24. 40, okay, 40 centimeter from 5. Okay, correct. 40 centimeter if you are saying both from 5, that is fine. But I have taken from second charge because this is closer. So that's why from one charge, first case is 10 centimeter. From the second charge, it will be 24 centimeter. If you calculate both distances from the same charge, it will be 10 centimeter and 40 centimeter, but you have to mention from which charge. If you do not mention from which charge, you will not get full marks. Okay, sir, should we find both? As I mentioned, if the question says at what points, so look for the question, there is a S, so that means you have to find both. If it is mentioned between the charges, between the points, between the charges at what point, then only this one is sufficient, only this one is compulsory. Okay, if they say only the point between the two charges at which point the electric potential is 0, then it will be this point. If they say at which points, according to NCERT it is given as which points, so that's why we have solved it here. Okay, so be ready for this. Anyway, this is an easy problem, mathematically easy, not super difficult. First of all, what you have to do, let me explain once more. So first is two charges are there, one is positive, one is negative, so electric potential will be 0 at 2 points. One point will be between the charges and second one will be near the smaller charge, okay. Smaller charge will decrease faster, larger charge will decrease slower, that is why it will be near the smaller charge, not this side. This side it is not possible. Okay, this side if you calculate you will get imaginary value. Okay, I some x plus iy, like that you will get. So this will be not realistic value, is not possible, but in this side obviously it is possible. So first you take the distance x from one charge, so automatically it will be 16 minus x from the other charge, because the distance between the charges are given in this question. So you calculate the individual potentials, but what mistake I made while solving this question is that I simplified it. Simplification was actually not required. If you had directly put like I have done in the second part, if you had done it in the first part, the answer would be much smaller and simpler. Okay, you just need to do that. V plus V minus equals to 0. So it will be coming out k into 5 into 10 to the power of minus 8 divided by x minus k into 3 into 10 to the power of minus 8 divided by 16 minus x. Okay, 10 to the power of minus 2 will be there common, and that will be equals to 0. So if you do that, all the constant will cancel, only you will directly get this equation. Okay, one mistake I made, I individually calculated this electric field, which was actually not electric potential, that is actually not required. You can directly write it and then start simplifying from the beginning itself. If you had done that, it would be smaller. Okay, the solution would be much smaller, like I have done in the second part. Second part is much concise, where we have calculating the electric potential due to this, okay, which is this one, and electric potential due to this will be 16 plus y. So just simplify it and you will get the answer. But mention from which charge you are calculating. Very important, from which charge. Okay, for example, I got 24, Amya got 40, both are correct, but Amya did not mention from which charge he got the answer, but I have mentioned both charges, so I will get full marks, Amya will lose 1 mark. Okay, so make sure you mention from which charge. Yes, you can do as long as if you mention that, okay, I want to do it from 5, okay, I want to do it from 5, that is also fine, okay. Then it will be y, and this will be y minus 16, that is also fine. You can take from this point as well, but I took from this point because that is simple. I feel that is simpler, okay. Just give you a perspective that it will be closer to the smaller charge, okay. To explain that point key, it will always be closer to the smaller charge, not this side. This side it is not possible. If you are mentioning, it will be beyond -3, okay, beyond -3, that is you have to mention, okay, because on which side it is. Now next, parallel plate capacitor with air between the plates has a capacitance of 8 picofarad. 1 picofarad equals to 10 to the power of -12 farad. What will be the capacitance if the distance between the plate is reduced by half and the space between them is filled with the substance of dielectric constant 6? Now this may not be a full-fledged 5-mark question. They might add 1 or 2 part to this question, but yes, silly mistake can make you lose marks, so small silly mistakes you should avoid. If this question is coming as a 5-marker, they will add one more part saying that this capacitor is connected, now this capacitor is connected to some certain voltage, what will be the charge stored, okay. So this itself is a 3-marker question. So if this question is coming, they will add one more 2-marker to it, okay. So obviously we know that capacitance of air capacitor is A epsilon naught by D, which is given by 8 picofarad, okay. Now what they are saying that we are decreasing the distance by half, so the new distance is actually D by 2, and we also have added a dielectric medium of dielectric constant 6, okay. So what is the new capacitance? The new capacitance will be A remains same, epsilon naught remains same, but along with that you have to multiply the dielectric constant divided by the new distance, which is D dash. So what is this? A epsilon naught divided by D by 2 into K, or you get this as A epsilon naught by D into 2K. Now this value is given in the question 8 picofarad, so 8 into 2 into 6, okay. 12 into 8 is 96, so it will be 96 picofarad. This is a 3-marker question, but if this question is coming, they will ask you with one more question saying that if this combination is connected with a 100 volt supply, what will be the charge stored, what will be the energy stored. So this kind of energy questions can be asked. Yes, 96 picofarad, easy question. Next question, I think next question is slightly tricky. Next question is also easy. This question actually came once, I think not in the first paper, but second or third paper it came, 23 or 24 improvement exams. That time it was improvement exam. 3 capacitors of capacitances 2 picofarad, 3 picofarad and 4 picofarad are connected in parallel. What is the total capacitance of the combination? Determine the charge on each capacitor if the combination is connected to a 100 volt supply, okay. So 3 capacitors are here and connected in parallel combination. Parallel combination means easy, this can be asked in series combination as well, okay. So be prepared for that. So in parallel combination, the equivalent capacitance is C1 plus C2 plus C3. Remember, it is a capacitor, not resistance, okay. The students make mistakes in capacitor based questions is that they confuse between series combination of capacitors and series combination of resistances. Series combination of capacitors add like resistances in parallel. Parallel combination of capacitors add like series combination of resistances, okay. So don't make that mistake, that might make you lose marks, okay. So here it will be 1 by 2, sorry, not 1 by 2, what I am doing, 2 plus 3 plus 4, which is equals to 7 plus 9 picofarad. So equivalent capacitance is 9 picofarad. Okay. So total capacitance of the combination is equivalent capacitance, which is 9 picofarad, and determine the charge on each capacitor. Charges will be different in each capacitors. That will be given by first of all, in parallel combination. Remember that in parallel combination of capacitors or resistances, no matter, one fundamental thing remains unchanged, that is in parallel combination. In parallel combination, the voltage is same for all the resistances, all the capacitances and resistances if it is involving resistances. Okay, so in parallel combination the voltage is same. So when we calculate the charges, Q1 equals to C1 into V. Q1 equals to C1 into V. C1 is 2 picofarad, 2 into 10 to the power of minus 12, and voltage is 100. So charge will be 2 into 10 to the power of minus 10 coulomb, okay, or 0.2 nanocoulomb. Q2 will be C2 into V, which will be 3 into 10 to the power of minus 10 coulomb, and Q3 will be 4 into 10 to the power of minus 10 coulomb. Okay, clear? 200, 300, 400. Okay, 200, 300, 400 watt pico coulomb. If you are mentioning that 300, 200, 400, you have to mention the unit. Okay, yes, 300, 200, 400, not coulomb. Distortion, the marks are already gone. Okay, 9 picofarad is correct. So again, answer will be 300, 200, 400 picocoulomb. If you are answering in picocoulomb, 300, 200, 400 is okay. If you are answering in terms of normal coulomb, it will be 10 to the power of minus 10, minus 10, minus 10. If you are answering in terms of nanocoulomb, 0.2, 0.3, 0.4. So don't make these small mistakes. These are very, very fatal if you are answering. If you do the similar mistake in your exam, marks will be gone. If you just answer 200, 300, 400, you will get 0 marks. You will say, sir, I just wrote the unit wrong. No, you did the that will be considered lapse in the problem itself. So you will get 0 marks for that portion. Okay, this portion you will get 2 marks, but this portion you will get 0 marks. Now, a 600 picofarad capacitor is charged by a 200 volt supply. It is then disconnected from the supply and is connected to another uncharged 600 picofarad capacitor. How much electrostatic energy is lost in the process? This is slightly longer problem, require a little bit of understanding that what happening here. So first we are charging the capacitor to 200 volt by a battery. Okay, a battery of 200 volt is charging it. So this is volt equals to 200, and this is the capacitor. Now once the battery is capacitor is fully charged, okay, now it is disconnected and it is now connected to an identical capacitor of again 600 picofarad. Now this question is still easier because this and this one are same. Okay, so that will still save us some time. If they are not same, I will explain the process that also, but if they are same, that will be much slightly simpler. So both process I will be explaining. Okay. So first, this is the process what is happening. We have to calculate the charge stored. So once you have charged the capacitor to this maximum 200 volt, the charge stored will be constant in this case as well. The total charge in an isolated system is constant. Conservation of charge principle, that principle is applicable over here. Okay, so whatever charge is stored in this capacitor, that charge will remain constant in this system as well. Even if you have removed the battery and you have connected it to a new blank capacitor means uncharged capacitor, in that case also the total charge, whatever the charge remains over here, the charge will still be constant. Okay, now So what is the formula? So there is a shortcut trick to this question that I am going to show it to you. So we will calculate the charge stored. Initially, what is the charge stored? Initial charge stored is given by Q equals to C into V. Q equals to C into V. So what is the C was 600 picofarad, 600 into 10 to the power of minus 12, and volt is 200. Okay, so 1, 2, 3, 4 zeros are reduced. We get 12 into 10 to the power of minus 8 coulomb. So 12 into 10 to the power of minus 8 coulomb charge is stored in the capacitor plate. Now what? What is the initial energy stored in the capacitor? The initial energy stored is given by half CV square. CV square means Q into V, that is Q square by C. Okay, so this formula, if you use the this formula, that will be much simpler in this particular case. In this particular problem, this will be much simpler. So half into 12 into 10 to the power of minus. I will explain why this is simpler, and it will not matter if both are same, both are not same. No matter what question they will give you, if you use this method, you will always get the correct answer. If you use half CV square method, that will depend on capacitance are same or not. Okay, this method, it will be almost independent. So you get 144 into 10 to the power of minus 16 divided by 2 into 6 picofarad, means 10 to the power of minus 12. So 600 into 10 to the power of minus 12. Okay, so yes, 72, 100, 12. So 12 into 10 to the power of minus 18 minus 12 minus 10 minus 6, right? Minus 10, 16 minus 6 joules. 12 into 10 to the power of minus 6 joules. Let's see. Now, so this is the initial energy stored. You have to find the final energy stored as well. Now here you see that charge of the combination will remain the same. Charge of the combination will remain the same. Only thing that you need to calculate the equivalent capacitance when two capacitors are connected in parallel. When they are connected like this, they are actually connected in parallel combination. Okay, because their starting point and ending point are same. Okay, so this is a parallel combination of capacitance. So in the case number 2, the equivalent capacitance is actually C plus C, that is 2C. So if they are not same, also you can use the method. So suppose this is 600, this is 200, you can add 600 plus 200. Okay, so this method is independent of the whether these capacitors are same or not. Okay, and trust me, the method is almost same length, 10 to the power of minus 10 farad. Okay, so this is the equivalent capacitance. Now what is the energy stored? Final energy is half. Charge is same due to the conservation of charge. Charge is same, only capacitance value changes, so it will be half into 144 into 10 to the power of minus 16 divided by 12 into 10 to the power of minus 10. So 12 cancels, we get 12, and 2 cancels, we get 6. So this will be 6 into 10 to the power of minus 6 joules. Okay, so final, as you can see, final energy is less than that of initial energy. So the energy lost is difference between initial minus final, which is 12 minus 6 into 10 to the power of minus 6, that is 6 into 10 to the power of minus 6 joules. If you use this method, okay, no matter whatever is the second capacitor is, you will be able to answer them quickly without much difficulty. Okay, understand this method. Zina Khan, how many marks from this model paper, how many marks from model paper? Okay, you will get 30 to 35 marks from model papers. Okay, 30 to 35 marks if you solve all 3 model papers. Okay, that is the historical trend. Now, understood? Any doubt about this question? Okay, you didn't understand the distortion. What is the problem? Tell me. Zina Khan, paper is by design, paper will be easy, 40% questions will be easy, 40% will be medium, 20% will be hard. That is the design of the paper. Now let me continue quickly. Okay. Okay, understood. Okay, next question. Now this question, I don't know why in the NCERT they have given this figure. This figure is not anyway. This is a very standard problem. I don't think this figure is required. Anyway, let's see. Figure shows a series LCR circuit connected to a variable frequency, a 230 volt source, L equals to 5 Henry, C equals to 80 microfarad, R equals to 40 ohm. Determine the source frequency which drives the circuit in resonance. Obtain the impedance of the circuit and amplitude of the current in the resonating frequency. Now, even though the problem is very simple, there is a trick in this question, which is amplitude of the current. I will explain that. Okay, first let us calculate the resonance frequency. Resonance frequency, how to calculate? Resonance frequency is given by 1 by 2 pi square root of L into C. So few formulas you have to remember. To solve problems from this chapter. So this is one of them. This is one of the most important formulas, resonance frequency. So how to calculate? 1 by 2 into 3.14 into, now here this chapter questions, numerical questions from this chapter are just straightforward formula based, but you require a calculator. Only thing is you require a calculator, because you cannot possibly solve these questions without using a calculator unless the values are given so. So L is 5 Henry and capacitor is 80 I'm not sure it is millifarad or microfarad. In the book I saw it is millifarad, so let me use millifarad only. Okay, milli means 10 to the power of minus 3. Okay, milli means 10 to the power of minus 3. So it will be 1 by 2 into 3.14 into 4 into 10 to the power of minus 1. Okay, it will be, and 1 by 2 into 3.14 into 0.4. Now 0.4 square root is not 0.2. 0.4 square root is not 0.2. Okay, 0.04 square root is 0.2. So if you multiply this, you get 0.4, and you're thinking, okay, square root of this is 0.2, that is wrong. So make sure you do not make these mistakes. You have a calculator where you can do square root. So you use that calculator, find the square root, take that value and multiply it. Do not try to mix and match between calculator and your head. Okay, that because it is very common that people write that 0.4 square root is 0.2, which is not correct. Okay, it is not correct. 0.04 square root is 0.2. 4 square root is 2, but 0.4 square root is not a rational number. It will be an irrational number. Not irrational, it will be a decimal number. Distortion is saying frequency is, sir, in the last question, how do we know that it is connected in parallel? Okay, so it is mentioned that if you read the question, it is disconnected from the supply and is connected to another uncharged capacitor. So once it is disconnected from the supply, so it is, if it is connected to another uncharged capacitor, obviously it will not be connected like this. If it is connected like this, okay, then this capacitor do not have any current, so charges will not flow, only this will be charged, this capacitor will still remain fully charged, this capacitor will still fully remain uncharged, so no energy change happens. Okay, only way to distribute the charges, you have to complete the circuit. To complete the circuit, you have to connect them. So once you connect them, now you see that, so these, you go back to this configuration, you will see that, so they are connected like this. This is the only possible way to connect two capacitors. Okay, no, nothing else is there. If it is a battery there, you can connect it through different way. If it is a resistance involved, you can connect it in series combination as well. But because only two capacitors are connected, only two capacitor, only three capacitor, only 5 capacitors are there, then also multiple combinations are possible. But when it is only two capacitors are there, then they will always be connected in parallel. Okay, that is the thing. If there are more than two capacitors, two of them will be series, one can be parallel with them. That kind of combination is possible. But you are not appearing for JEE exam, so those kind of questions are in JEE. Even not in JEE advanced exam, you might see those kind of question. But in your board exam, this configuration will be coming. So if this configuration is coming, then that means they are in parallel combination. Okay. Now, so this is what is the value of frequency? 0.025, okay, or 0.25. Mohi, because it is mentioned frequency, you cannot calculate omega. Because it is mentioned frequency, you cannot calculate omega, you have to calculate the frequency. So 0.025 I am assuming is correct. So let's say this, but I think 0.25 might be correct. Just check once. If it is 0.025, I am fine with it. So anyway, so this is the frequency. You have to calculate in Hertz unit, not in radian per second. That is not omega, but you have to calculate F naught. Second part is obtain the impedance of the circuit. So what is the impedance? Impedance of the circuit at resonance. At resonance, what happens is that XL equals to XC. XL is equals to XC. That means obviously impedance is exactly equals to resistance. You don't need to calculate XL XC. You just need to show that XL is equals to XC. That means at resonance, impedance will be equals to resistance, which is equals to 40 ohm. Okay, now they ask you now also calculate the amplitude of the current. So current here, this value, this voltage is VRMS. If nothing is mentioned in the question, always remember voltage is given in RMS value only. Unless it is mentioned peak value of voltage, it will always be RMS value. So current in this case will be current RMS, that we will calculate. IRMS equals to 230 divided by 40, that is 23 by 4. This is RMS current. They ask you amplitude of the current. Amplitude of the current, that is small I m, is equals to IRMS into root 2. You have to do this. Make sure you understand this. This is a new question straight from your NCERT. So if this question comes and you are saying that, sir, I have only solved IRMS, I have not calculated maximum current, then 1 mark will be deducted if you do not calculate this portion. Okay. 8.13, okay, let's say. Let me see, maybe, possible, 8.13 ampere. Let's see the answer. Yes, 8.13 is the answer. So it will be 0.5 Hertz. Okay, Gia, check your calculation. I took your answer, but it turns out to be slightly mistaken. It will be 0.25 Hertz. Okay, it will be 0.25 Hertz. Yes. Gia, check your answer. It will be 0.25 Hertz. Okay, so make sure you understand this. This is something new, and NCERT has a tendency of giving new questions from your state board has a tendency of giving new questions straight out of NCERT, so that if some controversy happens, they will say this question is from NCERT, so we will not take any responsibility if you are not able to solve it. Okay, so make sure you understand amplitude of current means you have to calculate IM, and by default, if nothing is mentioned, voltage is always given in RMS value. So here this 230 volt is RMS value. Okay, no matter what, you cannot say that this is maximum voltage. If it is mentioned maximum voltage, then that would be directly this calculation, like the way you do generally. Okay, you divide the voltage by the impedance and you calculate the current. So that is generally valid when you are calculating RMS values. Okay, so make sure you understand this problem, and at the end you have to multiply √2 if the question says amplitude, and amplitude is missing in the beginning part. If it is mentioned that when amplitude of voltage is 230 volt, then directly you can say IM equals to VM by Z. Here it will be R. So this is valid when in question itself this voltage is given as amplitude or maximum voltage. So in that case this calculation is correct. Okay, so understand this small change in the question. Now next, an AC source of frequency 50 Hz is connected in series with an inductor of 1 Henry, a capacitor of 90 microfarad and a resistor of 100 ohm. Does the current leads or lags the voltage? Calculate the phase difference between current and the voltage. Okay, interesting question. So here frequency is given, obviously voltage is not required for this problem, so that is not given. So this is basically not, I think it is not from your NCERT, but from your question bank. So XL equals to 2 pi f into L, omega L, generally omega L, but omega, obviously omega will not be given to your question. In last 10 years papers, if it is question based from AC, they always give in frequency. Okay, they always ask frequency. So 2 pi fL, so 2 into 3.14, you cannot take the full value of pi, obviously. F is 50 Hz and inductor is 1 Henry. So it will be 314 ohm. XL is 314 ohm. What about XC? Now let's calculate XC. XC is 1 by 2 pi F into C. So these two formulas are backbone of this chapter, and the resonance formula. Okay, and impedance. So these 4 formulas, if you remember, you can solve any question. And phase difference we will learn. Phase difference can be asked, may not be asked, but these formulas are always be asked. Okay, so it will be 1 by 2 pi. 2 pi is 3.14. Now calculate the XC. 14 into F is 50 into C is 90 microfarad. Okay, now this value can be tricky if you are using a calculator to calculate, because 10 to the power of minus 6 will be very difficult to handle. So how to handle this kind of questions, especially using calculators? Okay, scientific calculators it is easy, but normal calculator it will be difficult. So first you take this top side 10 to the power of 6, then you multiply 2 into 50, generally it will be 2 into 50. Okay, so it will be 100, and there is a 90 in this particular case. So you can reduce the values. Okay, you can reduce the values. You will get this as 10 to the power of 3 divided by 3.14 into 9. Okay, 1, 2, 3 zeros cancel. So that's why it will be 10 to the power of 3. So basically what you got? You got approximately XC equals to 1000 divided by approximately 28. Approximately 28. I'm not sure, but this is still much more manageable than the value you are calculating at this stage. Okay, So you have to use the calculator. After some simplification, use the calculator to calculate XC. Namaskara XYZ XRs gaming. Question number 10, why not half CV square? I explained, Komal, why not half CV square. I will explain once more. What is your question, Iconic? Sir, please reply support, sir. This is live, Iconic. I replied you in the past also when you ask a question. Saundarya, if capacitance is more, it takes. If inductance is more, it lacks. Yes, correct. What is the value you got? Hello, Megha. Hello, Sanvi. $35.7. Okay, Komal, I am explaining. Just wait for a second. 35.7 ohm. Okay, so as you can see that XL is more than XC. So we see that XL is greater than XC. That means it is an inductive circuit. It is an inductive circuit. So inductive circuit means current is lagging. Current is lagging the voltage. Current is lagging the voltage. So inductive circuit, if XL is greater than XC, then current is lagging. Current is lagging. Sir, in the derivation for magnetic field at axis, you use one current element instead of two current element. They give 5 marks. You have to explain that in the case that y component is 0. You only have to use one element. Okay, you don't need to use two elements. But while explaining that, you have to mention that for this y component will be upward, and if you take a diametric opposite point, the y component will be downward. That is why y component will not be there, only x component will be there. So that you have to explain, but you have to take only one element, because when you are doing the entire integration, you are getting 2 par. Okay, if you are using 2 element, that is also fine. If you are using 2 element, then integration will be only pi r, not 2 pi r. Okay, so if you have practiced using 2 elements, okay. If you are using 1 element, that is also fine, but you have to mention why y component cancels. Okay. So 2 element, 1 element, both are fine. 2 elements generally is not, I personally do not do 2 element because it is little confusing for some of the students. One integration is sufficient. You have to explain why there is a 2, why there is not 2 over here. That will be little complicating, and students do get confused with this. Okay, so that's why I use 1 element, but I mentioned that y components will not be there because of the symmetry of the circle. You can mention that due to symmetry of the circle, okay, the y component of dB will not be there, only dBx, x component of the magnetic field is present. Okay, let's see. So current is lagging. Now how to calculate the phase angle? Phase angle is calculated by tan inverse XL minus XC by R. Now remember that this is okay, fine, you get XL greater than XC. In the exam, suppose you get XC greater than XL, then here you have to put a modulus sign. Do not take this value negative. Do not take tan inverse negative sign. Take this value positive. Only difference will be current, instead of lagging, will be leading by that angle. Here current will be lagging by this angle. In that case, current will be leading by that angle. Do not worry, you take the positive sign. You can write XL minus XC modulus in if XC is more than XL. Do not use negative sign there. Okay, do not use negative sign inside the tan. Unless you are very expert, you can write what is the meaning of that, if you are able to interpret the meaning. Okay, because plus and minus, the answer will be completely different. Okay, so do not write that. Now here it will be 314 minus 35.7 divided by the resistance is given here 100 ohm. Okay, it will be around tan inverse. if I remember correctly, 2.79. Okay, 2.79, and that will turn out to be around 70 degrees. Okay, 70 degrees. Current is lagging by an angle of 70 degrees. Okay, but flux, what is flux? If you use XC minus XL, that is also fine, but but XC, both cases you have to use two different formulas. Okay, if XC is greater than XL, you use XC minus XL. If it is XL is greater than XC, you have to use XL minus XC. So I just tell my student to remember that you have to take the positive value. Subtract them, take the positive value. That is basically modulus of this. Okay, you can use XC minus XL, that is also okay. Otherwise, this is slightly easy to remember. Okay, XC minus XL or XL minus XC, student get confused which one we have to take. But if you remember that it is actually the positive value, that is far more convenient than taking plus and minus. Okay. Sir, is it important to put tan inverse value? We can leave it. See, it depends on, really it depends on the examiner. Some examiner give full marks over here. Some examiner says that you are given a tan inverse table, so why not find the value? I will explain tan inverse value at the beginning of my second lecture at 8 p.m. So do join there. I will explain it once more, how to read the tangent table. Don't worry, it is not super difficult. Tangent table you can easily find the values, not super difficult. Even if you calculate suppose 71 degree or 72 degrees, that is also acceptable. Okay, because 10% allowance is there. So if you write 71, 72 or 69, all are acceptable. Okay, you may not be able to exactly 70 degrees, not required. Okay. Now I think Komal Kaushik was asking one question, that why question number 10, he was asking some query. Okay, why I have not taken half CV square? You can take half CV square here. Okay, so you can use half CV square in this particular case. Okay, and half CV square in this particular case, but obviously capacitance will be different and V will also be different in this case. So you have to calculate the V as well. So in the second step also you have to calculate V. Not only equivalent capacitance, you also have to calculate the V, then only you will be able to solve this. Okay, whereas if you use Q square by C formula, Q you calculate once and you can use the same Q in both cases because charge is conservative. So I have avoided one step where you have to calculate V. First case V is given. Okay, anyway you have to calculate Q. Q you have to calculate V in the second stage. Okay, so Q is common. Using this Q, you can calculate V in the second stage, and then you use half CV square to calculate the voltage, calculate the energy stored. So that's why I have avoided in the same problem why we should need to calculate V, because without even calculating V, we are able to solve this question. So this step is compulsory. This step is compulsory. Okay, so in between you have to calculate V for the second stage and then you can solve this question. Now for this particular problem, half CV square is still okay because 200 volt was there, so it should be equally distributed among the capacitors because both of them are same capacitances. If they are not same capacitance, then it will be a longer process for you to calculate the potentials. Okay, so that is why I avoided this confusion. I used much more simpler value because formulas is same, half CV square Q square by C. If you forget this formula, how to remember? Half CV square, okay, half CV into V. CV is Q, so half QV, okay, and V is obviously Q by C, so half Q into Q by C, that is half Q square by C. So if you forget this formula, you can use how to remember it. This is a way you can remember it because this is the most fundamental formula. From here, all the formulas can be equated, right? So only thing I have not used half CV square because I avoided calculating one extra step. So you have to do one extra step here. But if you do this method also, fine, because you don't need to do any extra processing. Clear? Yes, Aisha. If you are watching me from the beginning, you should be able to answer all the question. Yes, next question. A series LCR circuit with R equals to 20 ohm, L equals to 1.5 ohm and C equals to 35 millifarad is connected to a variable frequency of 200 volt AC supply. When the frequency of the supply equals the natural frequency of the circuit, what is the average power transferred by the circuit in one complete cycle? What is the natural frequency? Natural frequency means nothing. This question is, I have added it. Natural frequency is nothing but resonance frequency. Natural frequency is resonance frequency. Okay, so at natural frequency means when the circuit is at resonance basically. So this question is from your NCERT. Okay, they instead of mentioning resonance frequency, they have mentioned natural frequency. Okay, so natural frequency means nothing but resonance frequency. So first is average power transferred to the circuit in one complete cycle in that will be given by power delivered, average power delivered in one complete cycle is given by V RMS into I RMS. Okay, V RMS is given. You can calculate I RMS, you can calculate average power given into the circuit. Okay, so what is I RMS? How to calculate I RMS? I RMS is equals to V RMS, or you can use one more thing. Because I am saying that I want to save some time, so V RMS square divided by R divided by Z in this case. Now because the circuit is already in resonance, so Z should be equals to R. You don't need to calculate anything. Okay, very easy question, but language wise question might seem difficult. Okay, average power delivered is Vrms into Irms, which is equals to Vrms square divided by impedance of the circuit, and because the circuit is in resonance, the impedance is actually equals to the resistance of the circuit. So Vrms is given 200 into 200 divided by impedance. Our resistance is 20 2 cancels, you get 2000 watt. Unit is watt. Average power 2000 watt or 2 kilowatt. 2 kilowatt, 2000 watt, whatever you are comfortable, you can leave the answer there. Now second part is what is the natural frequency? Natural frequency is F naught equals to 1 by 2 pi square root of L into C. That is 2 pi into L into C. L is 1.5 Henry and C is 35 millifarad. So calculate it, someone please. 1 by 6.28 into 15 by 10. Calculate this first, okay, then you calculate, simplify it, okay. P is 2000 watt, yes, correct. Sir, all these numericals enough to score 10 marks? Usha Charya, yes and no. If you are planning to memorize all these numericals and you are hoping that these questions will come in the exam, no. If you are understanding the process, yes. Okay, that is for guaranteed. I have explained all the formulas, all the concept, okay, some intricacies of the questions. For example, what is the meaning of amplitude of current? What is the meaning in case they ask capacitors are connected like that? So all different varieties of questions we are solving today. So those varieties of the question related concepts, maybe sometimes two different concepts will be combined. If you are able to solve these questions, you will have the confidence that whatever question is coming, I will be able to solve them. That is important. Especially the AC chapter. AC chapter questions are very, very common, okay. Only few things you need to remember: XL, XC, Z, then phase difference, resonance frequency. Okay, someone please calculate the resonance frequency. Okay, Mohi is saying 0.003. Okay, maybe it is correct, 0.003. Okay, hertz. Let me see. I have done the calculation. No, it will not be the correct answer. Check the answer once more. It will be wrong. Gia is saying 15.26. It will be 0.7 hertz. Let me use my calculator once. So square root of 1.5 into 35 into 10 to the power of minus 3. Ten to the power of minus 3, you can make it as 0.00 0.001. So it will be, here you will get this value will be 0.23. Okay, now it will be 1 divided by this value, .28. It will come out around, not, this is not correct. So while calculating, it will be 0.69, approximately 0.7. So remember that if you are calculating, say, resonance frequency or square root of such in certain cases, always simplify step by step. Okay, yes, 0.71 is correct, but remember 0.71, 0.69 all are correct based on what you have taken here. Both will be, can be correct. If you take 0.22, it will be 0.71. Okay, anyway, now remember that while solving this can be tricky if you are trying to solve the entire thing at one go. You cannot do that. You are only having a simple calculator, so always use this one first. Okay, and 10 to the power of minus 3, that is easily manageable, 0.001. So use that while multiplying. Okay, especially for resonance frequency. For other cases it will go up, you can cancel some of the values. For resonance frequency, 10 to the power of negative value, you have to take it like this. Okay, now next, a sinusoidal voltage of peak value. So here if you see that the peak value is given, that means this is the maximum voltage, this is not RMS voltage. Okay, peak value means this is the maximum voltage, not RMS voltage, is applied to a series LCR circuit in which a resistor of resistance 5 ohm, a pure inductor of inductance 32 millihenry and a capacitor of capacitance 800 microfarad are connected. Find the resonance frequency, calculate the impedance and power dissipated at resonance. Similar question. Okay, but power dissipated can be tricky if you are not careful. Now let's see. So first of all, we have to calculate the resonance frequency. Resonance frequency is 1 by 2 pi square root of L into C. Sometimes they will give you the resonance frequency and they will ask inductor is this value, what will be the capacitance. Okay, so make sure you are prepared for that as well. Sometimes phase difference will be given and they will ask you what is the in capacitance. So that in that case you have to use the phase difference formula. So formulas will be same, applications can be different based on the question, but resonance frequency questions are very common. Okay, because it can be tricky if you are not careful. Okay, so inductor of 32 millihenry, milli means 10 to the power of minus 3 and micro means 10 to the power of minus 6. Okay, now let's see. 1 by 2 into 3.14 into 10 to the power of minus 7. So 32 into 8 into 10 to the power of minus 7. Okay, again similar problem. Slightly tricky but not super. We will solve it. 2 into 3.14 into 32 into 8 means 2 into 16. 32 into 8 is 256. So square root of that will be 16. And we have square root of 10 to the power of minus 7. Now square root of 10 to the power of minus 7 can be tricky. So what we will be doing, we will be simplifying this. 2 into 3.14 into 16 into 10 to the power of minus 3 into square root of 10 to the power of minus 1. Okay, so square root of 10 to the power of minus 7 means square root of 10 to the power of minus 6 into 10 to the power of minus 1. Okay, so that is 10 to the power of minus 3 into 10 to the power of minus 1 in square under square root. Okay, so this one will be power halved, obviously square root means, but this one we cannot have anything. Okay, so this one you have to calculate, that is 10 to the power of minus 3 into 0.1 square root. 10 to the power of minus 1 square root means 0.1 square root. Okay, now calculate that. So we get resonance frequency equals to 10 to the power of 3 divided by 6.28 into 10 to the into 16 into square root of 0.1. Okay, this value can be calculated using your calculator. 31.5. Let's see who is correct. Komal Kaushik is saying 0.031. It will be slightly more than 0.031. We check. Let's see. 0.1. Square root of 0.1 is 0.31. Square root of 0.1 is 0.31, not 0.031. Square root of 0.1 is, so it will be 1000 divided by 6.28 into 16 into 0.31. Okay, it will be 0.31. Now let's see. So it will be 1000, and even if you are using your mobile phone calculators, use the simplified mode. Do not go for the advanced mode. 6.28 into 16.3. So it will be 33.1. 33.17. That's what I got. 33.17 I got. Okay. 33.5 is slightly more, but okay. 33.847. Okay, whatever you got based on your approximation, you will get a different value. Anyway, this is okay. This is fine. Amaya frequency will be 33.17 Hz, not 1 Hz. Okay, 33.17 Hz. Gia got 32. Okay, that is also okay. Okay, now next part is calculate the impedance and power dissipated. Impedance part is easy. Impedance part is at resonance, impedance is equals to resistance. At impedance, impedance is equals to resistance. Okay, because XL equals to XC, so that is equals to I think 5 ohm. So 5 ohm is the impedance. Now what is the power dissipated at resonance? Power dissipated, again, power, average power, either you use VRMS, IRMS, or you use half peak value of voltage into peak value of current, okay, or you can use this as well, half peak value of voltage square divided by resistance. Because peak value is given, you cannot simply calculate the current, or you can take the this value as RMS, okay. You have to take this half, you have to take this half. Make sure you read the question carefully, whether it is mentioning peak value or normal voltage. If it is nothing is mentioned, means RMS. If peak value is mentioned, means it is Vmax, not the VRMS, okay. So it will be half of Vm is 220 square divided by 5, that will be 22 into 22, 1 2 zeros divided by 10, so 0 0 cancels, and you get 22 into 22 is 448, I think 484, okay, 484, 4840, okay. Why it is so? Why it is not simply V square by R? Because it is peak value, not the RMS value. So here you have to add a half. Average value in normal AC is half of peak value square divided by resistance, okay. You can calculate the maximum current as well and use this formula as well, that is also fine. You can use this formula as well, okay. So I think this answer is wrong. This answer is wrong because while calculating I assume this is 80 microfarad, that's why this value is wrong. Do not consider this value. This is correct answer, okay. Otherwise, while calculating power average at resonance, you have to take half of this value, okay. Make sure you use half of this value, okay. Next, a screen is placed 90 centimeter from an object. The image of the object on the screen is formed by a convex lens at two different locations separated by 20 centimeter. Determine the focal length of the lens, okay. Here we have a lens, a screen over here, an object over here, and a lens. Now at two positions of the lens you will get the image on the screen, okay. There was a derivation on this. The derivation is no longer part of the syllabus. This question is there in your NCERT textbook, okay. So I decided why not practice it, okay. So here this is the distance D. There is a shortcut formula for this kind of problem. If you see this kind of problem, you should consider yourself lucky, okay. You don't need to do the derivation in the exam hall. You can directly use the formula which says that D square minus small d square divided by 4 into D. This is the focal length of convex lens when you are getting the image for two different positions of the convex lens, okay. So D square here is 90 centimeter. Now for lens problems you do not need to convert it into SI unit, okay. Everything will be, unless it is power related question, minus 20 square divided by 4 into 90. Now calculate this and tell me the answer. Wow, Mohi has already answered it. Let's see. Calculate someone and please tell me the answer. 8100 minus 400 divided by 4 into 90, okay. It will be 7700 divided by 4 into 90, so 770 by 36. Yes, I think you are correct. It will be around 20. Answer will be around 20, 21. Okay, 36 2s are 72, it will be okay. 21, 22, let's see, 21.4 should be the answer. Yes, 21.4 should be the answer. Just this is easy problem, just to give you an idea that if you see this kind of question, you do not need to do this derivation. This can be complicated. The question is actually complicated if you try to solve it in conventional method. But if you know this formula, you can directly use this formula. Yes, it is allowed, it is accepted, and you can get the answer. If you try to solve it in conventional method, u1, v1, and then take the value, then u2, v2, take the value, that will be very long and very tedious, and answer will take ages. If you know this formula, this problem will be solved in 2 minutes. Okay, original method is very long, very long. The derived formula, this is a very particular kind of problem where this formula is actually come from this derivation, and then you can use this formula. Okay, next, at what angle should a ray of light be incident on the face of a prism of refracting angle 60 degrees so that it just suffers total internal reflection at other face? The refractive index of the material of the prism is 1.524. Okay, so here we have a prism. Okay, angle of the prism is 60 degrees. Refractive angle or angle of the prism is same. Now suppose a ray of light incident on this prism. Okay, so this angle is I. Now once it falls on this prism, okay, this is the angle of refraction R, and then it passes directly through the surface dividing these two planes. Okay, so this angle is is 90 degrees. So this is the any angle slightly more than this, it will suffer total internal reflection. Okay, this is the critical case. That means this angle should be critical angle. This angle should be critical angle between the media. Okay, so here we have here we have a glass, and refractive index is 1.524. Okay, let's not write mu is confusing. Let me write refractive index formula n. Okay, so total internal reflection on the other face means this face. Okay, so this is the critical case. Understand, the diagram is very, very important. This angle is critical angle. Okay, this angle is critical angle. Okay, this tiny angle is critical angle. Mohi, are you checking the answer in the textbook? Sir, object distance should we take negative? Yes, object distance you should always take negative. Object distance should always be negative. Image distance can be positive, can be negative. Focal length for convex it is positive, for concave it is negative. Be it mirror, be it lenses. Okay, just remember, convex positive, concave negative. No matter if it is lenses or mirror, does not matter. Concave negative, convex positive. Okay, this way all the problems you can solve. Lens and mirror have different equation obviously, but concave is always negative, convex is always positive. Now so first we will start with this junction. Okay, and in case of a mirror, in case of a prism, the angle of prism is given by sum of the internal angles. So I critical plus R. This is from geometry we know. Okay, so sum of the internal reflection angles is actually equals to sum of the angle of the prism. So if you add these two angles, this critical angle and this R, you will get the angle of the prism. So this is the first equation. This is equation number 1. Second, we will start with this surface, okay, when the total internal reflection is happening. For total internal reflection to happen, okay, the refractive index must be equals to 1 by sine IC, okay, or sine IC equals to 1 by 1.524, or IC equals to sine inverse of this, sine inverse of approximately 2 by 3, okay. You need to calculate that angle using the sine cos table, okay, which will sir, I am only having textbook, I am not having textbook. Okay, you should have at least, sir, but you already did all type of numerical now, sir. King Hunt, yes, we have solved all type of numerical, but today I am only solving specially for NCERT numericals. That can be tricky because NCERT numericals, I solve few of the numericals. Language can be tricky if you are not familiar with the understanding of the NCERT numericals. Then even though the problem is same, even though the answer can be solved easily, but if you are not aware that of the language, because there are some different language used in NCERT, you may find it difficult, okay. Tell me this value, sine inverse of this, okay, IC is 29.7. Example question, if you can look into them, okay. Example problems are good. Some of the example problems in NCERT are difficult, okay, especially if you consider all the chapters numericals, okay. Some of the example problems are difficult. So you are saying IC will be 29.7 degrees. If you can check them out. Example problems sometimes gives you are done to give you a perspective of the concepts, perspective of the relationship between the variables. They are not as an example, but for example, one question was there to show you that 1 coulomb charge is very huge amount of charge, okay. So that there was a question that there was some charges are getting accumulated, how many years it will take a huge amount of time. So that is just to give you an idea that 1 coulomb charge is a huge amount of charge. So those kind of questions are there. Drift velocity normally is very low value, so those kind of questions are there in the NCERT solved problems. You can check them out as well if you get time, okay. They are not super exam oriented, but yes, conceptually good. So diagram is a ray of light is falling on this prism, okay, and it says that on the second surface of the prism the ray is suffering total internal reflection. Now how can a ray suffer total internal reflection? If the angle of incidence is slightly more than critical angle, and we cannot calculate if the angle is slightly more than critical angle. We can only calculate if it is exactly equals to critical angle, okay. So we are basically considering the critical case. Critical case means where angle of incidence is such that the ray, when it is falling on the other half of the prism, it is passing exactly between the glass medium and air medium. That is, it is actually the critical angle. So incidence angle on this surface, the incident angle on this surface must be equals to critical angle. So this angle must be critical angle, okay. So this angle of incidence, this is the normal drawn, this is the normal drawn, okay. All the angles are always measured from the normal. This is the normal drawn. That means this angle is 90 degrees, this angle is 90 degrees, this is the critical angle. So this is the critical angle between these two surfaces. You can use Snell's law, you can use this formula to calculate critical angle. You can use Snell's law saying that n sine IC equals to 1 sine 90, and then you write this, that is also okay. If you directly write the formula for critical angle, that is also okay, okay. So then we are solving it. What is critical angle? Critical angle, do you know what is total internal reflection? Master Muthu. Any possibility they may give from example problem? I have not seen in the past, but I have seen question coming from NCERT exercise. Okay, NCERT solve problem I have not seen that it is coming. Maybe once from the current electricity chapter, drift velocity related question was there. Similar question came, but those kind of questions are there in your exercise problem as well. So you may not, you cannot be sure. Okay, Master Muthu, so then it will be very difficult for you to understand what is critical angle. So total internal reflection happens, it was actually there in your class 10th standard. Okay, when the light is traveling from denser medium to rarer medium, okay, what happens, as the angle of incidence increases, the ray of light slowly bend away from the normal. Now that will also be foreign to you because you have not understand why the light ray will bend when traveling from one medium to another. That is called refraction of light. So when light is traveling from a denser medium to rarer medium, okay, the ray of light bends away from the normal. Normal means not normal, abnormal kind of normal. It is the angle of, it is a line which is drawn at the point of incidence which is perpendicular with the plane. Okay, this is called angle of incidence, this is called angle of refraction. Now Snell's law is there which governs these two angles. Now Snell's law is there. Now if you have not studied Snell's law, then you should go back and check my video on law of reflection and law of refraction that I did in class 10th. Okay, I have not done it in this session, but yes, Aditi ma'am also did our channel. You can check that out as well. Okay, so now at certain angle of incidence, what happens, that this ray passes exactly between the plane separating these two media. Okay, this is called critical angle. This angle of incidence is called critical angle, because any angle greater than this, the ray will come back to the the first media itself, and this reflection is called total internal reflection, because no light exit into the first medium. No light exits into the second medium. So this is called total internal reflection. It is a 100% reflection without any refraction. Okay, this angle is called critical angle, for which angle of refraction becomes 90 degrees. Okay, now I know you may have a lot of doubt, that's why I am saying you that you should go and check my class 10th video in the old channel. I used to teach in class 10th, or you can check our current channel where Aditi ma'am is teaching about total internal reflection, law of reflection, law of refraction as well. Okay, now so this angle is 29.7 degrees. So we have calculated IC. So angle of refraction in this surface we can also calculate, which will be 60 degrees minus IC. IC is 29.7. So this will be approximately 30.3 degrees. Okay, I hope you are telling me the correct values. Distortion is saying is 41 degree. Okay, so someone said 29. Oh my god, I was wrong. It will be 41 degrees. You are telling me the values, I am not doing it myself. Okay, whatever value you will tell me, I will do that. I will teach you how to calculate from sine inverse, cos inverse, tan inverse table, don't worry. So this will be 41 degrees, so it will be 29 degrees. Okay, so from here we calculated the angle of refraction. Now we will use the Snell's law at this point. So refractive index of this medium is 1, refractive index of this medium is n. So 1 into sine I, because I is in this medium. So 1 into sine I equals to n into sine of r. This is Snell's law. Okay, and we are trying to calculate the angle I. So sine I equals to 1.524 into sine of 29 degrees. Okay, so now you have to calculate, first you have to calculate sine 29 degrees, multiply it and then take a sine inverse to calculate the angle. Okay. Yes, correct. It will be 19 degrees. So first you have to calculate sine 19 degrees, then you multiply it with 1.5 and then take a sine inverse of that value to calculate the angle I. Now calculate it. Tell me the value. 41, 40.5, fine, no problem. Now I will do some cheating because I can do that. You should not do that cheating. Sine inverse. Okay, it will be 41. Okay, it will be approximately 41, correct. And then we are doing it sine 90 degrees. Okay, sine 19 is approximately 0.33. So it will be 1.524 into 0.33 approximately, which will be to 1.524. It will be approximately 0.5. So I will be approximately equals to 30 degrees. Okay, so I will be equals to approximately 30 degrees. Okay, half 0.5 means what? 0.5 means half. You don't need that exact accuracy. Okay, if you have used the sine table over here, sine table over here, and if you get it very close to 0.5, you can take that step and you can take, okay, this will be very close to 30 degrees. Okay, so 30 degrees is the answer for this question. Very interesting question. Okay, and this is from your NCERT textbook. If you are wondering, this question is directly taken from your NCERT textbook. So if this question come, I hope everyone watching this video right now should be able to solve it. Okay, 29.7 is okay, but as I mentioned, in the exam hall you are not allowed to use scientific calculator in your mobile phone. You have to use sine table. So after getting this value, if you get approximately very close to something which is known, you can take that approximation. That will be easier. Okay, rather than calculating 0.495 and then you searching in the sine cos table, better to take the approximation there itself and solve it. Okay, this is, you will get full 5 marks if you write 30 degrees, and if you will get full marks if you write 29.7 degrees as well. You will get full marks if you write 30 degrees as well. Okay, double convex lenses are to be manufactured from glass of refractive index 1.55 with both faces of same radius of curvature. What is the radius of curvature required if the focal length to be 20 centimeter? Now this is a question from your NCERT textbook. If you see your model question paper 1, similar question came with one more part added to it. Okay, so if you cut it, I think that question was, if you cut it from the middle, what will be the next focal length? Okay, but anyway, so this question is from your NCERT textbook. So obviously LensMaker's formula that says n minus 1 by r1 minus 1 by r2. Okay, now if both surfaces for a equiconvex lens, so the lenses are convex, so this is r1, this is r2. Now if you see in this particular case, r1 is positive. Why? Because it is on the positive x-axis. This is the positive x-axis, this is negative x-axis, so r2 must be negative. So we can say that r1 and r2 are actually equal, okay, with a negative sign. Okay, and that equals, if they are actually equals to a constant value, say r. So we can put that value over here. The focal length is given here 1 by 20 centimeter. N is 1.55 minus 1, and 1 by r1 is 1 by r, and 1 by r2 is minus r. Okay, so it will be 1 by 20 equals to 0.55 into 2 by r. So r equals to 1.1 into 20, that is 22 centimeter. Okay. Now if this is immersed into water, what will be the refractive index? Everything will remain same, only thing you need to change it here. So if it is immersed into water, the refractive index will be n glass by n water. Okay, this is an easy question, but there will be a part question other than this. Part question will be this lens is now taken and added into water, what will be refractive index? If this lens is cut into half, what will be the focal length? If you cut it into half like this, okay, the focal length will be just double. If you cut into half, focal length will be just double. Okay, if you cut it like this, the focal length does not change. If you cut it like this along the axis, the focal length will be doubled. Okay, and if you immerse it into water, then same formula, everything will be same, only thing this focal length will be changing. Obviously r value you have to use that, and in the model paper they are asking you, I think it is immersed into water. So if you immerse it into water, then it will be, this n will be replaced by this new focal length you have to calculate, r value will be the same. Okay, what is this? So why R1 equals to R2? Because it is a, first of all, it is a double convex lens. Okay, secondly, it is mentioned that radius of curvature required if the focal length is to be 20 centimeter. Also mentioned that both faces of the same radius of curvature. Both faces have the same radius of curvature. It is mentioned in the question. Instead of that, it can be mentioned equiconvex lens. Equiconvex lens, equiconcave lens. Equiconvex lens means both sides have same radius of curvature. Equi means equal. If it is not mentioned, here it is mentioned in words, both surfaces of the same radius of curvature. So that is given in the question. Okay, it is given in the question, that's why R1 equals to R2. But sign wise they are different. Obviously one is on the right hand side positive, another one is on the left hand side which is negative. Okay, this surface comes first, this surface comes first, so that's why it is positive, and that next surface is negative. Okay, that's why plus and minus. So 22 centimeter is the answer. Next, a prism of angle 60 degree produces an angle of minimum deviation of 40 degrees. What is the refractive index? Calculate the angle of incidence. So prism of angle is given 60 degrees. Okay, minimum deviation is given 40 degrees. They ask you what is the refractive index. Refractive index is very simple, sine A plus minimum deviation divided by 2 divided by sine A by 2. Okay, or sine 60 plus 40 by 2 divided by sine 60 by 2. Okay, or this will be sine 50 degrees by sine 30 degrees. Okay, sine 50 degree will be approximately very close to 53 degrees, which will be 3 by 5, 4 by 5 approximately. I am taking a wild approximation, 4 by 5, okay, divided by half. Okay, refractive index will be 8 by 5. It not exactly accurate, but it will be very close. Okay, sine 53 degrees is known, 53 degrees is 4 by 5. So I have taken very close to 50 degree. That is a wild thing. You can calculate it exactly from the table. Okay, sine 50 degree is very easy to find. Now what is the angle of incidence? Angle of incidence is equals to A plus delta m by 2, which is 60 plus 40 by 2, which is 50 degrees. Okay, Okay, 1.532 whatever you get, yes, 1.532. I just said, as I mentioned, it is a very wild approximation. Okay, I is 50 degrees, yes. Okay, now next easy question, not too much think about it. If the same prism is immersed into water, what will be the new delta M? That can also be asked. So remember that the only thing you need to change in this refractive index. Okay, refractive index will be changing. If you are considering in air N, if you put it into water, it will be divided by the refractive index of the water. Now determine the current in each branch of the network shown in the figure. Now this question again came in 24, not exact the same question, but this question is from NCERT, unbalanced Houston bridge. This kind of question came in 2024. Okay, I don't know the answer for this question, so we will be solving with you. So suppose this current is I1, okay, this current say I2, this current will be I1 minus I2. Okay, this current say I3, this current will be I3 plus I2. Okay, total current is I. Total current anyway we can calculate I1 plus I3, but first of all let us understand this. So this current is I1, okay, this current is I2, this current is I3. So these three are fundamental things, and this current will be calculated by Kirchhoff's junction rule. So if this is I2, I1 is going in, I2 is going out, that means this current will be I1 minus I2. Here I3 is coming in, I2 is coming in, so it will be I3 plus I2. Clear? Generally, if the question comes in your board exam, they will ask you what is the current through this 5 ohm resistance, that is the galvanometer. What is the resistance, what is the current through the central galvanometer? They will change the values. First of all, you check that this is not a balanced condition. Okay, 10 by 5, 5 by 10, not balanced. So this is an unbalanced Houston bridge. So how to tackle this? If you are comfortable with circuit diagram related questions, you can solve it. If you are not, then you should skip circuit diagram related questions. So we will take 3 different loops. One loop is this one loop is this one, and one loop will be this one. Okay, first of all, total current in the circuit, I equals to I1 plus I3. I1 plus I3 should be equals to total current I. Okay, this is not a simple question. So first we will use A, B, the D point is missing. First we will take A, B, D, A. This is the first loop. So in the A, B, D, A loop A, B, D, A. So when we are applying in this loop A, B, D, A, what is the current drop? 10 into I1. 10 into I1. For this loop, we are going from A to B. Current is going from A to B, so it is positive. Next, we are going from B to D. Current is also going from B to D. So I2 into 5 will also be positive. Okay, basically it's a Ohm's law in advanced form. Ohm's law says that voltage drop across a resistance is V is equal to IR. Kirchhoff's law says that you add all these voltages and you get the EMF. Okay, now next we are going from D to A. We have to close the loop, so that's why we are going from D to A, and we are going in the opposite direction of the current. So it will be minus 5 into I3, minus 5 into I3, and that is equals to 0, because if you see in the loop ABDA, no cell is connected. Yes, Pranav, just wait. I will try to complete it as soon as possible. Okay, this is the only long problem, otherwise we will close it. Some doubts came, that's why the session went a little longer. So 2I1 plus I2 minus I3 equals to 0. Okay. So this is equation number 1. This is equation number 1. Next, we will take the loop B, C, D, B. Loop B, C, D, B. Okay, in this loop again starting from B going towards C, so current is so voltage drop will be positive 5 into I1 minus I2, 5 into I1 minus I2 Next we are going in the opposite direction of the current. Current is going in this direction, we are going in the opposite direction. So 10 into I3 plus I2. So plus 10 into I3 plus I2 plus D2B. D2B is 5 I2. D2B is 5 I2, but again it will be in the opposite direction, so it will be negative. So these two will be negative, and that is equals to 0. Why negative? Because obviously this is the positive direction, we are going in the opposite, so it will be negative and no EMF, that's why equals to 0. 5 common, it will be cancelled. I1 minus I2 minus 2I3 minus 2I2 minus I2 equals to 0. Now add these two. I1 is only once, I2 is 1, 2, 3, 4. So minus 4 I2 minus 2 I3 equals to 0. Okay. This is equation number 2. Next, so you see that there are 3 variables. 3 variable means we require at least 3 equations to solve them. So next we will be using A, B, C, and through this say E, okay, through the cell. So now we will be using A, B, A, D, C, E, A. You can take any loop, you can take A, B, C, E, A also, that is also fine. We are taking this loop, this will be, I feel this will be slightly easier. Current through 10 ohm resistance is obviously I1 plus I3, that is there, right? Because this current I1 is splitting into this, and when you add these two you will get I1 plus I3. So now first of all we will starting from here, current direction positive, so 5I3. Now we are going in the same direction of the current, 10 into I3 plus I2. Now we are passing through this resistance again in the direction, so it will be plus 10 into I1 plus I3, and that is equals to 10 volt. Okay, now divide by 5, I3 plus 2I3 plus 2I2 plus 2I1 plus 2I3 equals to 5. Equals to 2. We have divided by 5 both sides, right? So equals to 2. As I mentioned, it is not very simple. Unbalanced Houston bridge problems are not very simple. 2I1 plus 2I2 plus 5I3 equals to 2. Now this is equation number 3. Now you can simplify this using matrix method if you know how to use matrix method. If you don't know, take one value. For example, from this equation you can simplify I1, and then you put these equations I1 into these two equations and simplify. It will be longer, okay, but solvable. Okay. How to take I1 minus I2 and I3 plus I2. So see here, if you see this here, I have assumed this current is I1, this current is I2, and this current is I3. This I have assumed at the beginning. Okay, this much I have assumed in the beginning. Now if I1 is going over here, suppose 10 ampere is going over here, 2 ampere is coming in this direction. So how much current will remain? Remaining current will be 8 ampere, because if you add these two, these are the outgoing current, if you add these two, you should get back the original current. Okay, so I have applied Kirchhoff's current law directly in the circuit diagram. Don't worry, if this question is coming in your board exam, this diagram will be provided. This current analysis diagram will be provided to you. You don't need to worry about it. Okay, you only need to apply the Kirchhoff's voltage laws and then simplify it. If you are good in mathematics, you can simplify this equation. This equation simplification is not easy. So not only, first of all, why these circuit diagram related questions I always suggest that tend to avoid, because first of all you have to construct the equations correctly. Once you have constructed the equations correctly, then you have to solve them correctly. So these two steps are very difficult. First of all, not only one equation, you may need to solve 2 or 3 equations based on the problem. And then once it is solved, then you have to solve those equations. That's why I suggest, now matrix method can be used, but I know, I'm not sure whether you are aware how to solve using matrix method. If not, then you have to take I1 equals to 4I2 plus 2I3, and then you have to put this in equation 1 and equation 3, then simplify it. I am not doing the simplification, but I hope you understood, right, Komal? Okay, Needy is saying I2 equals to minus 4 by 17. Yes, you can calculate. I have not done the calculation, but anyway, this will take longer time. If you are really interested, tell me, I will solve it in the 8 p.m. class, because I also have a class just within 1 hour 20 minutes. Okay, so I will see you again. Last question. The number density of free electrons in copper is estimated to be 2 into 10 to the power of 28 per meter cube. A copper wire of length 3 meter and area of cross section 2 millimeter square is carrying a current of 6.4 ampere. Calculate the drift velocity of electrons. How long does an electron take to drift from one end to the other end? Okay, so number density is given, length is given, area of cross section is given, current is given. Drift velocity is equals to I divided by NEA. So you have to remember that current is NEA into drift velocity. This is the formula. Okay, from here you can put the values and calculate. 6.4 divided by, number density is 2 into 10 to the power of 28. Charge of an electron is 1.6 into 10 to the power of minus 19, and area of cross section is 2 millimeter square. Millimeter square means 2 into 10 to the power of minus 6 meter square. Okay, millimeter square will be tricky, so it will be 4, 2 ones are 2, 2 ones are 2. Okay, so it will be 1 divided by 10 to the power of 9 minus 6, 10 to the power of 3 minus 25, 10 to the power of 3. 10 to the power of minus 3 is the answer, and unit of velocity is meter per second. Unit of velocity is meter per second. What about how long the electron will take? The electron will take to drift is given by time is given by the length of the wire divided by drift velocity. Okay, length of the wire is 3 meter and the drift velocity is 10 to the power of minus 3, that is 3 into 10 to the power of 3 meter per second. Okay, clear? Double slit experiment numericals, Master Muthu. Double slit experiment numericals, you are saying that you don't know what is critical angle, now you are asking double slit experiment. Okay, double slit experiment I will solve in my night class, so do join me in the night class. I will solve some more numericals there. Okay, Shruti, what is your question? Can you explain the question again? Which one, Shruti? Which question? Question number 18 is incomplete. Distortion is saying question number 18 is incomplete. Why it is incomplete? It is complete. Minimum deviation is given, angle of the prism is given. You can solve refractive index, you can solve the angle of incidence as well, right? Question number 20. Question number 20 is drift velocity of current in terms of drift velocity is given by NEAVD. N is number density. So number density here is given, number density of free electron is 2 into 10 to the power of 2 into 10 to the power of 28 per meter cube. Per meter cube means per volume. Okay, so number density unit volume, number of electrons per unit volume is given by this. This is N. Okay, charge of an electron is well known, that is 1.6 into 10 to the power of minus 19 coulomb. Okay, and area of cross section is given as 2 millimeter square. 2 millimeter square. Now millimeter square is not sufficient, you have to convert it into meter square. Millimeter square to meter square is 10 to the power of minus 6. 1 millimeter to 1 meter is 10 to the power of minus 3. So if you square both sides, you get millimeter square to meter square 10 to the power of minus 6. May I saying, sir, answer is different in 18th. Oh, that answer you ignore. That you ignore. Answer can I solved it something, I wrote it something, you can ignore that part. Okay. Answer I have only written it. So while solving it, somehow I may be in sleepy mode, I have done something else. Okay, I was solving yesterday some of the questions, maybe I have done some mistakes. Okay, clear? Okay, I will see you in 8 p.m. Go grab some snacks, have some break. Okay, then 8 p.m. do join me back. It will be a long live, so be prepared.